Um, so in section 15.3, we've been talking about logarithms. So we had started by defining what we mean by what a logarithm is, and it's basically the answer to an exponential equation, right? So like, what is the exponent, or what is the power of 2? Oh, right. Yep. So we had talked about logarithms last time, talked about what a logarithm is and how to evaluate a logarithm. Today we're going to talk about properties of logarithms, and specifically we'll talk about two types of problems that we'll use these properties of logarithms to do. And that's about the gist of the end of section 15.4, or 3, excuse me. So we have 4 properties of logarithms. So we name those 4 properties the product, quotient, and power properties. And then the 4th one is the change base formula. What the product property says is that if I have multiplication inside my logarithm, that changes into addition of the 2 logarithms. This property is equivalent to the exponential property listed here, because remember that a logarithm is really just like the inverse of an exponential. So this exponential property here, where when we multiply exponentials, we add the exponents. Here, if we're multiplying logarithms, we add the logarithms. It's like the analog to that property. Everybody's okay with that? So this property of logarithms is just a logarithmic translation of this property of exponents. Quotient property, the same idea. If multiplication inside the logarithms turns into addition outside, division inside the logarithm should turn into subtraction outside the logarithms. And again, that's equivalent to this property of exponents. Again, logarithms and exponents are inverses, so any property of exponents is going to have a corresponding property in logarithms. The third one, the power property, says that if I have an exponent inside my logarithm, I can move that exponent out front of my logarithm as a coefficient. This is equivalent to like the exponent of an exponent property for exponentials. Everybody feel okay to hear? Okay. And then our last property is this change of base formula, which is not something we're going to use to do these 2 types of problems we're about to show you. We'll talk about how you can use the change of base formula here at the very end. And that's not doesn't directly correspond to a specific property of exponents, kind of like a blend of a couple. So we're just going to kind of neglect that because I think it's more trouble than it's worth for you guys. Everybody's okay? Okay. I'm going to pause here because I still see a bunch of pencils going, and I know that looks like we're still kind of writing down our properties here because you need those. Okay. So the 2 types of properties that the 2 types of problems we're going to talk about are expanding and condensing. In an expanding problem, we're going to take one logarithm and break it apart into many logarithms. In condensing, we're going to take many logarithms and squish them all back together into a single logarithm. Everybody's okay with that? So one problem is going one way, the other problem would take you back to the start. Everybody's good with that plan? Okay. In general, when we're doing an expanding problem, we're going to do that by applying, in this order, quotient property, then product property, then power property, unless there's a set of parentheses that says, oh, you need to do this thing first. For condensing, because you're doing the opposite thing, we're going to use the opposite order. So we'll go from power to product to quotient for a condensing problem, unless there's a set of parentheses that implies you should be doing something else first. Does everybody feel okay? For your guys' test, I would want on my note card, I'd want those 3 power product quotient properties, and I'd want the order in which I'm going to apply those properties for expanding and condensing problems. I think that those are both note card or half sheet, good half sheet information. These expanding and condensing problems, 100% will appear on the test. Everybody's okay? You ready to do some examples now? All right. So we'll do some expanding problems first. So just to review, since we're doing expanding, the order that we're looking to apply our properties are quotient, then product, then power. Everybody's okay? So when we're using the product, quotient, and power properties for expanding, we're looking to go like this direction. So we're looking to start with the single logarithm and breaking it apart, right? So we're going in that direction for expanding. So for my expanding problem, I'm going to start by looking inside the logarithm.
Would you do log base 3 to 5 plus log base 3 x squared plus log base 3y?
Eventually, yes. I'm just going to walk through a step before that, though, to show that there's nothing to do there. So if I look at my order, I should be looking for a quotient property first. So I'm going to look inside the logarithm. Do I see any division going on inside that logarithm? 5x squared times x squared times y. No division. Quotient property is done. Nothing to do for that. The next thing in our order is the product property. So I'm going to go ahead and look at 5x squared y and look for any multiplication going on in there. How many times is multiplication going on in there? Twice. There's a multiplication symbol between the 5 and the x squared, and another multiplication symbol between the x squared and the y. So I can apply the product property in there 2 times because I have 2 instances of multiplication. Everybody's okay? So what I'm going to do is above the equal sign, I'm going to write product property times 2 to tell myself when I go back and look at my notes, what am I doing here? I'm applying the product property 2 times. Do you need to do that in your homework or on your test or quiz? No, I'm only doing this in the notes, so when you go back and look at this and you're like, what the heck was he doing here? That thing should remind you of like, oh, he's using the product property here twice. That's all that's doing. And as Kendall had said, basically everywhere there is a multiplication symbol, we're going to have an addition. And our logarithm is going to wrap around each of those things. So we'll have log base 5 or base 3 of 5, log base 3 of x squared, and then plus log base 3 of y. I know you know what to do. And I'm excited that you're excited too. Is everybody okay with how I've gotten to here? Okay. Next, what we're going to look for is the power property. And I have 3 places that I have to check for the power property because now I have 3 logarithms. So if I look at the 5, is there a power on 5? I mean, there's a 1 there that we don't write, but that doesn't matter if I bring the 1 to the front. Whatever, no big deal. You don't have to worry about that. Do I see a power for the x squared? Okay, so we'll need to do a power property there for sure. Do I see an exponent on the y? No, so we can avoid doing a power property there. So we have one power property to do. So the first logarithm just stays the same. And the last logarithm, that stays the same. But for the second logarithm, the log base 3 of x squared, that one we do have a power property to do. What does the power property say that we need to do? We move the exponent to the coefficient. And we go through one more time and check, but everything is done. And that would be our final answer. Okay? On your test or your quiz or whatever, I would like it if you only did one property per step. Okay? So you do your quotients, do your products, you do your powers, and then you're at the final answer. Everybody's okay? You could take more than one step if you want to do the product as two separate steps. That's okay. You can do more steps, but try not to do less than that. Don't go straight to the final answer, even if it's easy for you to do. Everybody's okay? All right, should we do the next example? All right. So these last two examples, we have some tricky things going on that I want to put here so that I've shown you the tricks before I use them again on the test. So just as a heads up, the tricks going on in B and C, each of them have their own, each of them have at least one trick going on here that I'm going to try to fool you on, that I'm showing you now, so that the trick doesn't work as well the second time around. Everybody's ready? Okay. So we're expanding. What's the first property we look to use in expanding? So again, the order's here that we're using, right? Quotient property is correct. If I look inside my logarithm, is there any division going on?
Yes.
Yes. So I do have a quotient property to do. So the quotient property is going to give me log of the numerator minus log of the denominator. Is everybody okay there? Okay. The next thing I look for is which property? Product. If I look at log of square root x, is there a product property there? Is there anything multiplied? No. So there's nothing to do there, so I'll just recopy that logarithm. Then I'll look at log of y squared z cubed. Is there a product property there?
Yes.
Yes. So we do have one product property. So we'll do that product property. Now, I've made a mistake in the way I wrote that last step. I made this mistake on purpose because I would say, without having shown you the trick that's happening here, every single one of us would probably make the same mistake that I've just made, which is why I did it. And I want you to now take a look at it and see if you can see what the problem is or what the mistake is. Ian.
Should it be y squared minus c cubed?
Yes. Why is that? Why is this addition symbol supposed to be a minus?
Because it's initially it's log root x minus.
Yeah. So because that piece was subtracting, when I do the property or the product property, the result of that product property needs to be subtracting. So there's like a distributing negative thing going on here, right? Now, do you have to show me the distributing the negative step, or can you just write minus minus? What do you guys think? You can write just minus minus, just as long as you catch it. What do you want to look for in the beginning? You want to look to see if you have multiplication going on in the denominator. That's your cue to know that there's going to be a minus minus going on. Is everybody okay there? Okay. All right. So we did our product property, and I included a simplification step. It's okay to go, to go straight from, this step to this step would be okay. You don't have to do the intermediate if you don't want to. I'm going to leave it there, though, so you can see why the minus happens. All right. We've done quotients. We've done products. Then the last step is power properties. How many power properties do you see here? 3 is correct. So 2 of them should be really obvious, the y squared and the z cubed. Where's the third one?
The square root.
Why is there a product or a power property on the square root?
It's technically x.
Yes, good. So we have 3 power properties we can do. So we just move those exponents into the coefficient, and we're donezos. Is everybody okay with what we did here? Is this feeling all right? Again, as long as you're moving kind of carefully and slowly through this, this usually goes pretty okay for students. It's not a difficult concept, but it's new, and there can be some, like, Mr. Kulik can play some tricks on you to try to trick you, that it's worth showing you the, what are some of the tricky things I can do.
How do you get 1/2?
So again, the square root of x is the same thing as x to the 1/2. Yes, go ahead. Because, Tessa, if you remember, we have this property of exponents. And that's what we use to rewrite the square root of x as x to the 1/2. Does that feel good? Okay. And again, those properties of exponents, if you don't remember those or that you're not comfortable there, we wrote them all down, I think, in 15.3 or something when we did this, or part 1 of this set of notes. Those are good note card things also, right? All right. Next example. So what do we start by looking for? Quotient property. Do we see one? We do. So again, we'll have log of the numerator minus log of the denominator. Everybody's okay there? Next up is product property. How many product properties do you see? Where is the 1?
100x.
Okay. There's also a second one going on between the y and z, right? But what's the catch with that one? Not yet. Why not yet, Mark? Because it's under the same radical. So we'll have to do the power property around the yz and then come back and get the product property afterwards. Does everybody kind of see that? That's trick number 1 in this problem, is there's like an implied parenthesis here going on. I'll write it this way, right? That really I should think about that square root of yz as like 1/2 y times z. So I know I have to do the power property first before I can get into the product property, because we're working from the outside in, right? On order of operations. Okay. So we'll do one product property here. So leave that first guy alone. And I'll rewrite it with parenthesis and exponent, I guess, since we acknowledged that. When I do the product property for log 100x, how do I want to write that? Minus minus, right? Everybody's good with why we wrote it as minus minus instead of minus plus? Same trick as before, right?
Excuse me, can I
Yes.
borrow James Walker for a second?
Sure.
Appreciate it.
No problem. Okay. Everybody happy? What should we look for now?
Power.
Yep. How many of those do you see? Okay. Everybody's good there? Notice we're not done though, right? We still have some more we can do on this guy. Yeah, now we go back to the product property because now that we cleared the power off of there, we can go back and get that other product property that we had to skip before. Now I made a mistake. I did it on purpose. What also needs the 1/2? The log z. Very good. Again, notice that there should be like an implied parenthesis here that the 1/2 would have to distribute across. Do you need to show the step that I just showed? No, you could go ahead and just write it as 1/2 log y plus 1/2 log z and not show that intermediate step. I'm doing that because it's notes. I'm going to show you that. Here's the catch though, guys. Trick number 3. This isn't done. There's one more piece that you can do here. Yeah, so when I write log, what is the base there when there's nothing there? That's correct. 10 is the base. Now, can I rewrite 100 as a base 10 number? What is 100 as a base 10 number? 10 to the second. And what do you guys remember about the relationship between log base and exponent base? Inverse. So that piece just turns into a 2. Right? The only piece left there that isn't crossed out is the 2. Well, we're all learning it for the first time, you know? And this is like a really complicated example, right? There's a lot going on in this one. Would I give you a problem on your test that has all these tricks going on all at the same time? No, right? Would be separated into separate problems, probably like at most one tricky thing per problem, right? Sure. Does that feel okay? You guys ready to condense? Remember, that's the reverse object, right? We're going to start with lots of logarithms and smush them back together into a single logarithm. Everybody okay with the plan? So to expand, we did quotient, product, power. To condense, we're going to do the reverse, power, product, quotient. Because it's doing the reverse thing. Instead of breaking it apart, it's squishing it back together. So you should do the properties in a reverse order. Okay. So, first property we look for is, hold on. So, remember when we were doing the, come on, go up here. Expanding property, we're trying to break these apart, correct? When we're doing a condensing, though, we're trying to put them back together. So we're kind of looking at going this direction. Everybody's okay? So for a condensing problem, we're looking for the product property, we're looking for addition between two logs. For quotient property, we're looking for subtraction. For power, we're looking for a coefficient times the logarithm, right? So just kind of reminding you, everything is in reverse when we're condensing, right? We're going opposite order and we're using the properties in the opposite direction. All right, let's go back here and look now. So first thing we look for is the power property. The power property is signaled by a coefficient in front of the logarithms. How many power properties do we see?
One.
Just one. It's that guy right there. So that's going to take that coefficient and move it into the inside the logarithm as an exponent.
I have to go mute and listen.
Okay.
All right, show you.
No, I believe you.
Thank you. Have a good day.
You too. Then we look for the product property. Do we see a product property? Hold on. Let's go back and look. What are we supposed to be looking for a product property? Because we're running in reverse. We're looking for addition symbol. Do we see an addition symbol? Yes, right? How many product properties do you see? One. And it's happening right here. So that's going to smush those together and make it multiplication inside the logarithm. Is everybody okay? So again, remember, condensing, everything is running in reverse, right? The properties are being used in reverse. The order in which we're applying the properties gets reversed. It's all reversed, right? Okay, the last step then would to be look for quotients. What's our Q for a quotient property? Subtraction. We got one of those. So there we go. Put back together into a single log, and then we're done. Is everybody okay here? Usually the condensing is a little bit easier for students because you know what the answer has to look like. Is it's once you got it all back into a single logarithm, you're usually done, right? Expanding, sometimes it's a little trickier to tell when you're done because there could be lots of, could be more things to do that are hiding on you. It's a little harder to hide them here in the condensing, although there's still tricks here that I'll show you on the next two problems. This first one, though, is about as straightforward as you can get, right? Nothing tricky. Let's take a look at the next one. What's the first thing we look for? Power properties. How many power properties do we, or what do we look for a power property?
Coefficients.
Coefficients. How many do we see? Good, I agree. So what's the one weird coefficient? The 1/2. What does an exponent of 1/2 mean?
Square root.
Square root. Is it okay if everybody that I just do that and skip writing it as exponent of 1/2? Okay. Figured it would be, but I thought I would check. Product would be next. How many product properties do you see? 1 is correct, but here's the tricky part. What two logs are getting product propertied? Well, that's what's written next to each other, but which logs should really get product propertied?
Log base 3, log base 3.
Yeah, these are the two that should be getting product property. Why don't I want a product property the log base 3 of square root y? Because it's negative. Yeah, if I go back and I look at my properties of logarithms, the product property, both the logs are positive, right? Everybody see that? So this is tricky. I did a tricky thing and wrote it in a weird order for you. Is it okay that I rearrange this so that the positive ones are next to each other? Absolutely, because I can do addition in any order I want, right? It's commutative. So I'm going to skip taking a step to rewrite those two next to each other and just squish them together. And then we'll do the quotient property. You see the subtraction. And nothing tricky there. It's always positive part over negative part. Oops, that was a z though. And that's our final. Everybody feel good here? Nothing tricky going on, nothing too tricky going on, right? The trickiest thing was like I wrote the logs in a weird order so that I was trying to trick you to apply the product property incorrectly. But that's easy enough to catch once you're seen like, oh yeah, I got to make sure that I'm not doing that. Okay, and then our last example is here. Now you should notice something right away that's odd about this example.
Here's a 5 on this.
Yeah, there's a constant all by its lonesome, right? Yeah, so Kendall's right on. She's saying that, oh, this must be like the same kind of thing that happened here where we canceled a logarithm with an exponent base to get that. So we have to build that back out, right? Everybody's okay? So that's right on. So let's take care of this first. Notice our logarithm is ln, which is the same thing as log base e. So 5 is going to be the natural log of e to the 5th. Is everybody okay with that? Because the log base e, that's natural log, will cancel the exponent base e, and that'll just give us the 5. Everybody's good? So we'll just rewrite that as our first step, now that we've established that. Okay. First step is, nope, before product is power. How many power properties do we see? I see 3. Remember, we're condensing,
Oh, right.
so we're looking for coefficients. So again, keep in mind the direction that we're going. Everybody feel okay? So far, so good? Okay. Here's the tricky piece. How many product properties do you see? You say that, I see 2.
Because there's an it's your no.
Yeah, so see those minuses, I can like factor out a negative. And really now, there are 2 hidden product properties going on. Little tip for you, when you're condensing, you never want to use more than one quotient property. If you're tempted to do the quotient property more than once, there was some factoring that you could have done to just done a product and then a quotient afterwards, which is the better way of doing it rather than having like multiple quotient. Yeah, you don't want to do that. That's not going to, you're not going to like the way your answer looks, and you're probably going to screw that up. Okay, so we do now see the 2 hidden product properties. Now, I wrote this extra factoring step so you could see where they were. Some of you guys saw it. I'm guessing some of us didn't, even after we noticed that there was 2 there. Do you need to write this intermediate step? No, you could go straight from the previous step to what we're about to do. That's okay. You don't have to give me that in between one. That's okay. And then we can quotient property as our last one, and we be done. So that's about all the tricks I can play on these kinds of problems. Again, on your test or whatever, I wouldn't expect to see more than 1 trick in a problem. But I didn't want to do like a million examples. I figured we'll just kind of cram a couple of tricks into each case. And those last ones got a lot of tricks in it, which is basically as hard as it can get, are those last ones. Everybody feel okay still? So that's condensing and expanding. The last thing we want to talk about is just using the change of base formula. So the way we use the change of base formula, if we go back and we look at that guy, it says I can take log base b of r and rewrite it as log base a of r divided by log base a of b. And the great part here is that we get to choose the value for a. Traditionally, that a is chosen to be either one of 2 things. What would be the 2 values that we would traditionally choose for a?
1 and 10.
10 is one of them. E is the other. Why 10 or e?
Because they have their, 10 is the base log.
The common logarithm is log base 10, yes.
And E is ln.
Is ln, the natural logarithm, both of which are traditionally buttons on our calculator. So if I wanted to do, for example, where did you go? Log base 3 of 10, I can rewrite this as like log 10 over log 3, or I could write it as ln 10 over ln 3, or if I was feeling real crazy, I could do something silly like do log base 2 of 10 over log base 2 of 3. All of these are going to give me the same answer. Now, this is a tad outdated. So let's see, we'll do log of 10 over log 3. And then we'll do natural log 10 over natural log 3. And then we'll do log base 2 of 10 over log base 2 of 3. And we'll observe that we're getting the same answer in all of these. Now, this is with the current calculators you guys have, not terribly useful because what else can your calculator do? I can just type in log base 3 of 10 directly onto my calculator and just press enter and get the number to come out. Now, previous generations of calculator did not have that option, so the change of base formula was something you would commonly use. Less necessary now given modern calculator technologies, but could still be useful in other contexts, although we wouldn't see that in this particular class. Everybody's okay with how to use the change of base formula, what that's allowing us to do? Okay. When Mr. Kulik was a high school student, you know how you had to do this. There's a table in the back of the book of logarithms. You had to look up, I need log base 3 of 10. I have to look up log of 10 and then log of 3 and type the decimals into my calculator and then do the division. That's how that worked. You had to look it all up in the back of the book because they didn't have, you just had a table of natural logs or common logs. I don't remember which one it was. You don't have one of them because you didn't need more than one of them. But that's how it worked when I was a high school student, which was
Painful.
well, you know what? You didn't know any better. Like, you're used to doing stuff like this.
Yeah.
It was tedious, but like whatever. You're just looking stuff up out of the back of the book. You had a bookmark back there for your table of logarithms. It's kind of a hassle to use because it also had it was constructed in a way that you could do log of any value up to 10, and then any decimal 0 through 9, and any decimal after that 0 through 9, and so you could get 6 decimal places or something out of it, which again made it kind of confusing to look at and get the hang of using, but that's what it looked like. Anyway, that is the gist of section 15.4. So your next problem set is going to be 71 through 98, which are all just expanding, condensing, and using change of base formula to evaluate logarithms, which should be pretty okay. Questions for me? So this will be part of Sunday's problem set, or will be due Sunday anyway. And we'll just kind of continue on with chapter 15. If you are a senior, you might have noticed that on the minor name page under the agenda, I have the tentative schedule for the end of the semester. We'll see about the chapter 15 test date. Again, this is all tentative, but that's the idea. Where that would be the last possible thing you'd be doing as a senior. That may end up being pushed as part of your exam, depending if we get to it or not. Maybe something that the juniors take the chapter 15 test, and then it's just part of the senior exam if you have to take an exam as a senior. We'll just kind of play that by ear. Feel okay, dudes? Okay, questions for me? Yeah, go ahead. All right, well, I'm gonna stop here.